Hi, we are the team Data Miners. Our project for Compy 255 data mining is insurance premium prediction. So, our agenda for the demo is to start with introduction and business understanding by Dhanashri, and then we'll see about the data understanding and data preparation that's involved in the project. This will be presented by Shravani. Then we'll see the different models that we've used and how we're measuring the accuracy. This will be presented by Chaitra, and then how we have deployed and what client side application are we using. This will be presented by Pragna. All right, so let's begin with the introduction. So, what is medical insurance? So, our project is insurance premium prediction in the context of medical insurance. So, let's see what medical insurance is. So, medical insurance is basically a contract which requires the health insurance company to pay some or all the cost of an individual's healthcare cost in exchange for a premium. So why is medical insurance very important is that it is very important for the individuals to possess insurance for healthcare. This is because if an individual or a family member comes across with a medical condition, it could be anything like a low to very serious medical condition, and the cost that's incurred for these medical conditions could be very high, and it would be very difficult to deal with this cost without the aid of health insurance to cover at least some of these costs. So that's why it's very important for individuals to possess healthcare insurance. What role does the health insurance company play here is that the primary focus of health insurance companies is to make healthcare more affordable by protecting the individuals from unexpected illness or accidents, which can easily cost people up to thousands of dollars. So, this is the introduction about what medical insurance is and why it is important. So, with respect to business understanding, so now that we've seen how medical insurance is important and how companies cover these costs for individuals, it is also important that these health insurance companies are benefited out of this deal. So that is what this project deals with. That's where our business understanding would come in. So while health insurance is essential and it's very beneficial to the paying customers, it is also important for the companies providing these services to get benefited out of this deal. So for this purpose, we're doing this whole step. So the purpose for this purpose, for that is in order to get benefited from this and maximize their benefits, it is important for these healthcare companies that provide healthcare insurance companies that provide healthcare insurance. They have to collect and understand the data of their customers to understand the features of the individuals. So what are the different features that corresponds to an individual, and how these features can affect the cost that they pay for their healthcare insurance. So the companies need to understand this in order to provide better services as well as cost the right amount to the customers, as charge the right amount to the customers. So what the purpose of this project is that the project aims to incorporate data mining within insurance. So here we understand and use various data features such as age, gender, number of dependents, smoking, BMI, etc. So we use various features such as these to determine the cost of premium to be charged by the health insurance provider for the customer. So this helps the insurance provider understand the customer needs and provide services and charge them appropriately. All right. So next we'll see about data understanding and data preparation.
Now let's see the steps that we have performed for data understanding. The main goal of data understanding is to gain general insights about the data that will potentially be helpful for the further steps in the data analysis process. So let's see the steps that we have followed. So first, the step in the data understanding is to load the data set. That means collect the data set and analyze it. So after loading the data set, our data set has 2675 records. That means the number of entries, and the total features are 7, of which one is the target variable. These are the first 5 entries. So as we know that there are 7 columns. One is age, 6 BMI children. So age is the age of the primary beneficiary, and sex is whether the primary beneficiary is a male or female. And body mass index is nothing but the amount of fat that a person has with respect to his height and weight. Next is children. Children, in the sense, we can say the number of dependents that will be covered in the insurance. Next is the smoker, if the primary person smokes or not. Next is the region where that person lives in the US, in which part actually the person lives. Next is the target variable, which we are gonna predict here. So for better understanding, we have renamed the columns expenses and children to premium and dependents. These are the last 5 entries. Next, if we see the different data types that we have in our data set, age, age, BMI, and the number of dependencies, and the premium. Those are all categorical, sorry, numerical, and the rest of them, which is sex, smoker, and region, are categorical. Um, Next step is that we have checked for missingness. If there is any missing value like NaN, not a number values in the data set, it looks pretty much clean. But if there are any missing values, we apply some imputation strategies like univariate imputations like mean, median, and mode. And uh, and also we can apply multivariate imputation strategies like mice. So since as our data set is very clean, we don't have to apply any such imputation strategies. Next step is we have seen how the target variable is described, like what are the number of entries of the target variable, and what is the mean, what is the minimum value of a person in the sense, the target value, the premium. So the premium value starts from 1121, and it extends up to 63770. So here we have seen about the target variable. Next, we'll see what is the correlation between each of these numerical feature with respect to the correlation coefficient. So here, if we plot this heat map, we can see that our target variable is 30% correlated with the age and 20% correlated with BMI, which is body mass index, and it is very minimally correlated to dependence. So next step, we have seen the relation between the number of dependents versus premium. That means if the number of dependencies, like if the person has a wife or a children, whether the premium increases or decreases. So here if we see, uh, even the person who has no dependencies tends to pay more premium. So in this case, here there are no children or no dependents, here the premium is greater than 60K. So we cannot just say that dependencies will increase the premium of that person. There is maybe the primary person may be having some medical issues, major illnesses or diseases. So for that, next we have seen the dependency of age with premium. Um so this is the scatter plot which describes the relation between age and premium. The general trend seems to be that the medical expenses increases with age, as we might expect. However, there is significant variation at every age, and it's clear that age alone cannot be used to accurately determine the medical expenses. So, since we cannot accurately determine the medical expenses, we have seen the relation with respect to smoke, whether a person smokes or not. So, here, if we see that this is scatter plot, there are three steps here, three different trends we can observe here. A person, the first is the largest cluster, consists primarily of healthy non smokers who have relatively low medical expenses compared to others. So, this is the first trend. So if we see the second cluster here, it has more smokers. It is kind of mix of both smokers and non-smokers. So it's possibly that these are actually two distinct but overlapping clusters with non-medical with medical issues and smokers without major medical issues. So next, this is the final cluster which has only which are like mostly who smokes. So from this trend we can say that a person who smokes and who has more uh, age we cannot say more, kind of it varies. It started from around 18, we can say 18 to 60 plus. A person who smokes more tends to pay more premium according to this scatter plot. Next we'll see how it varies with respect to BMI. Okay, here it appears that for non-smokers, this is non-smokers which is blue color, it appears that for non-smokers an increase in the BMI doesn't seem to be related to an increase in the medical expenses. So however, medical expenses seem to be significantly higher for smokers with a BMI greater than 30. So here if you see, it is greater than 30. Here the people who is smoking more tends to pay more premium. Now, till now we have seen the relation of target variable with numerical features. Next we'll see with the categorical variables, which is six smoker and the dependencies. Next we this is the box plot. This is sex versus premium. Here if we see from this box plot, although this medium looks quite same 75%, so this is in this box plot, this is a minimum. This one is 25, this is 50, which is the median. The median looks the same, but 75% of the female tends to pay less comparatively to male. So that's it, we can know from this box plot. Next, if we see smoker versus premium, it is very evident that the person who smokes more tends to pay more premium. Next, if we see with respect to region, all the medians are almost similar, so there is not much what to say insight that we can draw from this region feature. Next, we'll see the distribution of each feature. Okay, this is distribution of premium, which is the target label. From this plot, we can say that our target variable is power law, is following the power law distribution. It is clear that for more customers, the annual medical expenses are below the 10K. Only a small fraction, that means these small fraction of customers have higher medical expenses. So to better understand this, we have calculated the skewness of this premium feature. The skewness is 1.5, so which means that the data is highly skewed, so it is positively skewed. So from this plot, it we can say that our target variable is not normally distributed, and it shows peakedness here. It shows peakedness, and also it is right skewed. Next, if we see kurtosis, it is 1.4, which means it clearly says that our data is, I mean, the premium feature is heavily tailed. So, if there is such a tailed distribution, we will apply some normalization strategies like log scaling or Z score, min max scaling. So, similarly, let's check for other features. This is the distribution for BMI. From this plot, it is very clear that the data is normally distributed. That means it follows the normal distribution. We have also calculated the skewness and kurtosis. It is zero point 0.2, which means the data is fairly symmetrical here, and kurtosis is a negative value less than 0. So it indicates that the data is lightly tailed, so no need to apply any normalization for this particular feature. Next, we have seen similarly we have seen the distribution of age versus premium. So as we have seen earlier, the age doesn't depend much upon, that means the target variable, the premium doesn't much depend upon this age. Next, we have seen the female versus male. Female tends to be like more premium than male. And here we have seen BMI. It is like much of fluctuated because it depends upon the smoker. If a person who has more BMI value, if a person is more is is if a person is having more BMI and he tends to smoke more, then he tends to pay more premium. So it shows a fluctuating trend. Next, if we see with respect to dependence, here we can see a person who doesn't have any dependencies, but he's paying around 9k. But here, a person who has more, uh, if he has two or one dependence, he tends to pay 8k. So that means dependence alone doesn't affect premium. Next, if you see smoker, here the distribution, if you see a person who smokes more tend to pay more, as we have seen earlier. Next, it is we have seen the relation of the region with respect to premium. Here, northeast persons tend to pay bit higher comparative to the three other regions, but there is not much insight that we can draw from this. So till now we have seen how the data is distributed or how each feature is related to the target variable. Next, we will perform feature engineering and normalization techniques, training different models and then saving them, uh, and then making it more interactive for the users. So next, Dhanasri will continue with the feature engineering process.
All right. So now let's perform feature engineering on our data set. So why do we perform feature engineering? So we perform feature engineering to understand the different features in our data set and to understand the relationship of various features with the target variable. So this will help us understand the importance of every feature in the data set and how important these features are in deriving or arriving at the target variable. So here we've used feature viz in order to perform feature engineering. So this will help us understand what the most important features are and how they influence the target variable. We've also performed PCA to determine the most powerful features and which will help with dimensionality prediction. All right. So as we see here, we're performing, we're using Feature Viz to do feature engineering, and as Feature Viz only takes numeric data, so we're performing label encoding here. We're performing encoding in order to convert categorical to numeric values. So as we can see here, the data set contained male and female in the sex category, and yeah, the region also had a northwest and other categorical values which have been converted to numeric values now. So now we know that premium is the target variable here. That is, we're determining the premium amount that the health insurance company has to charge the individuals. So that is the target label here. So now on performing feature engineering, it uses Solov and XGBoost. So after using all this, we can see that the top features are listed here. So as we can see here, the attribute, the feature smoking or smoker has the most influence on the target label. We've already seen this in the uh, data understanding as well, where we can see that if a person is a smoker, then the premium amount that they have to pay is significantly higher than if they are not a smoker. So we can see that here. So here, as feature whiz points out to us, uh, these are the most important features that have the most influence on the target variable. So we'll start with a smoker, then their BMI, then age, and the number of dependents, then region, and then the sex. So yeah, so most for the four most important features selected here are smoker, BMI, age, and dependence. Right. Then we also perform PCA, which will help us determine what the most important features are. In order, this is in terms of performing dimensionality reduction. So here, the dimensions required to preserve 90% of variance is 4. Next, let's see about normalization and the different models that we're using.
Now, let's discuss about normalization. The goal of normalization is to transform features to be on a similar scale. This improves the performance and training stability of the model. Observing the above graph for insurance premium, it varies from 1121 to 63,770. It seems to be significantly skewed as the median 9,382 is much lower than the maximum value 63,770. Next, let's see about log scaling and how normalization helps in normalizing our data. Log scaling is helpful when a handful of values have many points, while most other values have few points. This data distribution is known as power law distribution. Observing the graph, data distribution of insurance premium follows power law distribution. Hence, log scaling is used to normalize. This is the before and after normalization using log scaling. Log scaling changes the distribution, helping to improve linear model performance. Next, let's look about standard scalar. The standard scalar will transform data such that its distribution will have a mean value 0 and a standard deviation of 1. This is done feature wise, in other words, independently for each column of the data. Given the distribution of the data, each value in the data set will have the mean value subtracted and then divided by the standard deviation of the feature data set. After we are done with standard scale, let's go to modeling. Here we are using a regression model. Regression can be defined as a machine learning problem where we have to predict discrete values like price, rating, fees, etc. We are using AutoML and sklearn to train regression models. In AutoML, we're using PyCaret and LazyPredict. Before that, let's look at the sklearn models. First one being linear regression. Linear regression fits a straight line or surface that minimizes the discrepancies between predicted and actual output values. We tried linear regression on insurance dataset and obtained a RMSE of 5796 and a R square of 0.78. Next is decision tree. Decision tree builds regression model in the form of a tree structure. It breaks down a dataset into smaller and smaller subsets, while at the same time as associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. We trained decision tree on insurance dataset and obtained RMSE of 4590 and a R square of 0.86. Next, we tried random forest. A random forest is a meta estimator that fits a number of classifying decision trees on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control overfitting. We tried random forest on insurance dataset and obtained a RMSE of 4478 and a R square of 0.87. Gradient boosting. This estimator builds an additive model in a forward stage wise fashion. It allows for the optimization of arbitrary differentiable loss functions. In each stage, a regression tree is fit on the negative gradient of the given loss function. We tried gradient boosting algorithm on insurance dataset and obtained a RMSE of 4328 and a R square of 87. Next is KNN. KNN, regression based on K nearest neighbors. The target is predicted by local interpolation of the targets associated with the nearest neighbors in the training set. We tried KNN algorithm on insurance dataset and obtained RMSE of 6136 and a R square of 75.75. Next, we tried XGBoost. XGBoost automatically models numeric targets, squared error function with random search hyperparameter optimization. XGBoost model trains with loss guide and histogram tree method to accelerate tuning. We tried XGBoost algorithm on insurance dataset and obtained RMSE of 4327 and a R square of 0.87. Next, let's look at model performance evaluation. In the XGBoost, we saw about loss function. Now, what is a loss function? Loss function specifies a penalty for an inaccurate estimate from a statistical model. Loss function specifies the penalty as a function of difference between the estimate and the true value. RMSE is used as a loss function. What is RMSE? It's mean squared error is finding the squared difference between actual and predicted value. Now, RMSE, that is root mean squared error, is the square root of the mean squared error. The formula is given here. The output value we get is in the same unit as the required output variable, which makes interpretation of loss easy. The next metric is R square. R square score is 0, then the above regression line by mean line is equals means 1. So 1 or minus 1 is 0. So in this case, both lines are overlapping, means model performance is worst. It is not capable to take advantage of the output column. Now the second case is when the R square score is 1. This means when the division term is 0, and it will happen when the regression line does not make any mistake. It is perfect. In real world, it is not possible. So we can conclude that as our regression line moves towards perfection, R square score moves towards 1 and model performance improves. The normal case is when R square score is between 0 and 1, like zero point 0.8, which means our model is capable of explaining 80% of the variance of the data. From the above observation, we can say that the performance, that is the RMSE and the R squared of the XGBoost model, is good compared to other models. So we will save XGBoost model for further testing of the data using the Pickle library. And gradient boosting is equally good. Once we have saved the model, we can use it interactively using the Gradio. With just 2 lines of code, we can have an interactive output, which is shown here. So given the age, sex, BMI, dependence, no, smoker or not smoker, and the region, we can get what is the premium they are going to pay. Next, we are going to use PyCaret. PyCaret is an open source low code machine learning library in Python that helps in preparing data and deploying single or multiple models for comparison. Using PyCaret, when we trained our regression model, these were the output of these were the output for the compare models function. We got gradient boosting to be having the better R square and RMSE, which was the same when we did with sklearn. Next, we use something called as lazy predict. We are trying to go through different auto ML capabilities as it will ease the process of model comparison. Another one which we used, as I mentioned earlier, was lazy predict. Lazy predict is again another Python library which is used to semi automate machine learning tasks. It helps to understand which models work better without any hyperparameter tuning. After getting all accuracies, we can choose the top 5 models and then apply hyperparameter tuning to them. It provides a lazy classifier to solve classification problems and lazy regressor to solve a regression problem. We have used lazy regressor as we are dealing with a regression problem, and we got gradient boosting to be the one which has a better R square.
So in the deployment phase, we are using Flask API as a backend where we are loading the model into the run, and we are using the best fit model to predict based on the inputs we get from request in the front. We are using JavaScript to make XHR request to Flask API with users input converted into XHR request. When the user clicks on form submission button, a form submission event is triggered, which in turn makes XHR request to Flask API. Once the request is done, the model evaluates the request and gives a prediction of premium, which is sent as the response back to JavaScript, which is shown at the front end as a text message. So this is the overview of deployment part. Next, we have screenshots of Anaconda prompt where we are deploying the Flask API. Currently, I'm deploying at my local port 5000. Next, now we have front-end HTML where the user is prompted to give input of various parameters like age, gender, BMI, number of children, etc. Once the user give the input, they'll get the estimated premium. Now let us go to the demo. Now let's run the Flask API in the background. So currently the Flask API is running. We have also got a debugger pin, which means the Flask is active. It is running at my local host, which is located at this IP address. When I go to that location, it will give me a hello message. It says that Flask API is up and running and we don't have any issues. So this is the home page of Flask API. And now we go back. Let me enter the details. When we'll get the premium based on the user inputs. When we go back to terminal, we'll see the input is getting recorded. So let me first give the inputs. Wait. So age Age is 25, male 31.3, number of children 2, smoking yes, and the region is southwest. So now if we predict the premium, it shows that the premium is 5,756.89. This is the premium. When we go back to terminal, we will see that the input is getting recorded and the output is calculated based on the model, and the same output is shown in the front end as well. And here comes the conclusion. By this project, we are able to help the healthcare insurance provider companies to predict the premium to the charge to be charged for the customers. Thank you.